Before we start, can I ask a general question?
Sure.
So I was thinking about like Ethereum, for example, they call themselves as World Virtual Machine, and Internet Computer is like gonna be World Computer, Internet Computer. So how, like I know that Internet Computer is planning to be cloud, decentralized cloud computing, and it's slightly different than being virtual machine. But I couldn't like understand very well the difference of Ethereum and Internet Computer in terms of like functionalities and problems that they are going to solve.
Yeah, it's not really about being a virtual machine. The internet computer is also a virtual machine, so that's not the important piece. The main
Okay.
difference is the amount of compute resources available to these machines. Um, Ethereum has a megahertz processor for all apps. They all must share the same megahertz processor. On the internet computer, a single application basically has access to a gigahertz processor, so 1,000 times more compute. And you have gigabytes of memory and gigabytes of storage. You have kilobytes of these things on Ethereum. So that is, I think, the main difference is the amount of compute resources are just way, way smaller on Ethereum. But Ethereum is much more decentralized and robust in other ways. So you just choose what you're looking for. So Ethereum is just really, really maximizing decentralization and not maximizing compute resources. The internet computer, I would say, is coming from the other end. But it's Do you want a virtual machine that has gigabytes? Is it basically giga level or something else? Ethereum and all those are basically something else. That's how I look at it.
So the trade-off is decentralization and robustness.
The what? Sorry?
The trade-off is decentralization and being robust.
I mean, it depends on how you really have to look into it, but Ethereum has a level of decentralization and a level of robustness that I think it'd be difficult for the internet computer to have. Does that matter for your application? I don't know. Right? You just have to think about it.
Got it.
Okay, cool. Yeah, thank you, Mood, for your question. And yeah, let's start. Welcome everyone to the third session of the TypeScript course organized by the ICP.Hub North America and also hosted by the Demergent Labs team, by Jordan Last, CEO and founder of Demergent Labs. Today we will dive in the episode number or chapter number 11th, which delves into Candid. And then let's see if we can move forward and have maybe touch some part of the chapter 12, the stable structures. But today we will focus in on Candid. Thank you, everyone. Anyways, these sessions will be recorded and are available in our YouTube channel. You can check it out whenever you have time as well. Let's start. Thank you, everyone. And thanks, Jordan, for your time. All yours.
Okay. Can I share my screen?
Yes, give me 1 second. Yeah, now you can.
Cool. Okay, here's the repo again. Here's the Azle book again. Today, chapter 11, Candid. So let me scroll down here. Let's see. Okay. This is an extremely important concept to understand on the internet computer. Let me just introduce a new language to you called Candid. It is an interface description language. It was created by Dfinity specifically for the internet computer, and it is used to define the interface or essentially define the methods of your canister. So all the functions that you're exporting. Last time we talked about how to export query and update functions or query and update methods. Method is just a function on a canister. Candid is a language that lets you basically specify the names and the types of the parameters and the return values of those methods. And by specifying everything in this language called Candid, it makes it very, very easy for canisters written in whatever language to interact with other canisters and to interact with other clients. And that is, the basic concept. So it's basically like an encoding and decoding format or language, or at least it makes it very easy to encode and decode, or to serialize and deserialize values as they're traveling across the internet from canister to canister or from client to client. So that is what Candid is at a high level. And now we'll, I guess, dive into how to use it. But basically, these are all of the Candid types, every single one. I also want to show you a really good resource. This Candid reference at internetcomputer.org. We refer to this all the time. This also has all the types and more information than we have here as well. But basically, Candid exports basically all these types for you to use in your application. And you have all of your primitives here, basically, right? We've got the text type, that's just a string. We have a blob, which is just a uint8 array. We have all natural numbers, natural numbers being basically positive integers. We have all integers. These can be negative. We have, these are bounded by bit values, basically. So this is 64 bits in size, 32 bits in size, 16 bits in size, 8 bits in size. We have float 64s and float 32s. Bool null, vec. Vec is like a list. Opt is something that's optional. It's either there or it's not there. A record, which is basically your object type. It's going to be complex, key value pairs that where the values can also be key value pairs. Variants, which are similar to enums, but they're algebraic in nature. We have funcs, which it's basically like a callback, a function you can pass around, or a higher order function. Service, a service is basically a canister. Principles, which are identifiers, and reserved and empty, which are weird. They're not that important, but we can go over them. So these are the types that you'll be using in Azle. And let's start with the text type. So text and string, the TypeScript string type, are basically analogous. So you don't have to import text if you don't want to, but you could import text. So right here, if you wanted to, you could actually import text. Boom. Text is just an alias to string, so same as string. And basically what you do is you take your types and whatever you just use them where you use TypeScript types. So if I say I return a string, then under the hood, this string value is going to be encoded using the Candid byte format, basically, or the encoding format. So it'll be encoded for you automatically and sent across the wire. And then when it gets to a client, as long as that client has your Candid file, remember these files here are generated for you automatically. As long as the client knows about this Candid file, and to decode, actually, the encoding format does have some sort of information about the type, so you might not need the file in all cases. But to decode, it'll basically look at that Candid byte encoding format and then decode it into whatever language environment you're in. So trying to get that concept across to you. This is all about encoding and decoding. You basically just import the types and you use them where you need them. So let's look at the next type, blob. So you can see here we're importing blob from Azle. And if I want to return a blob, I just say that the return type is blob, and it expects a uint8 array. So here's the creation of a uint8 array by hand, basically. If you want to receive one as parameter, you just tack it on right here. That's the parameter type. And then boom, this will be anyone who's calling this function. The bytes will come in, they'll be decoded for you into a uint array. And then you can return this and it will encode it back into Candid bytes for you. So, I mean, the idea is to abstract away the encoding and decoding from you so that all you have to do is think in terms of these types. Then we have nat. Like I said, nat is a natural number. So these are basically arbitrarily huge numbers. And under the hood, it's important to understand that under the hood, a nat is actually just a JavaScript big int. So yeah, just keep that in mind. It's not a special data type at runtime. It is actually a JavaScript big integer. NAT64, similar to NAT, but 64 bits in size. Keep in mind though, the 64 bits in size thing will be enforced by Candid encoders and decoders, hopefully. But under the hood, it is just a JavaScript big int. So it's not actually going to be only 64 bits in size. It could be, so however big your big int is under the hood. So just keep in mind that the Candid type, though you will get some type checking and stuff by your tooling, at runtime, the actual JavaScript values might behave a little bit differently than you expect. So it's actually JavaScript big int. NAT32 follows the same ideas, but it is actually a JavaScript number under the hood. And NAT16 is also a JavaScript number. And NAT8 is also a JavaScript number. Then we get to int, and remember ints basically can be negative or positive. And under the hood, it will be a big int. Under the hood, int 64 will be a big int. And under the hood, int 32 will be a number. And int 16 will be a number. And an int 8 will be a number. And remember, you just import these from Azle, and you tack them on where you need them. Okay, then floats. A float 64 is just a number under the hood. In fact, the JavaScript number is a float. I think it's an IEEE 754 floating point number. A float 32 will also just be a number under the hood. So there's really no difference between float 64 and float 32 at runtime, but your Candid tooling may enforce sizes for you. For example, if you call from the command line, then it's going to enforce float 32s on you. I believe that's a general concept. Bool is just a Boolean. So you just use the normal TypeScript Boolean type. Null is just null. Nothing crazy. Vec is any kind of list. Make sure you actually import the vec type and use the vec type. Do not try to use for example, if I want get message to be a list, I need to say vec string. And then, pretend that's a list. Don't say, string array or array or read-only array. It has to be a vec. Now, keep in mind, I've said this in earlier episodes, but we are about to release a major change to Azle in Azle version 0.18. It will change some of these things. So this is just for Azle. The current version of Azle has these rules. But the concept of Candid and the concept of these types, all that is going to flow into the next version, basically. Okay. Opt. The opt type is, I think that this is the first sort of algebraic or functional data type that we have here. An opt under the hood, it's a variant. And it's a variant with basically two branches or two possible values, some or none. This is in opposition to basically having null or undefined. Basically, it's strictly typed as basically an enumeration. And yeah, it can only have two possible values, some or none. So this is the recommended way, basically, to do anything that's optional. And yeah, you just wrap whatever type you want to make optional with the opt type. And I mean, do some or none. Nothing too crazy. If you want to check if you have an opt passed into you, then we pass in some optional value, an opt boolean. Basically, what this is at runtime is it's an object that might have a sum or a none value. So probably the easiest way, it might not be the most functionally correct way, but the easiest way to get a value out is to say, all right, if the property sum is in opt, then opt.sum is available to you. None is in opt, and opt.none should be there for you. Interesting. This is not behaving exactly how I expected it. Okay, we also have a special function called match, which you could use. This one's a little complicated to use. It very much follows the kind of algebraic data type system of Rust that Candid kind of embraces. So what a match function will do for you is you can put in a variant like opt, and then you basically make an object to handle every case in the variant. Sorry. So there's your sum value, and then there's your num value, and I'm hooking up two Lambda functions to handle every possible case. So notice here that sum, basically, if this opt at runtime has a sum value, then this Lambda function will be invoked with that actual value. If at runtime it is a none, it will be this will be invoked here, and there's nothing to pass in. So for example, if I want to basically unwrap this Boolean, then I can say, const, call that opt bool. Oops. In my actual bool, I can say is this, and then I guess in the none case, I can do, a c.trap or something. Not a bool. So basically, this concept of variance is probably going to be very new to you if you're not already familiar with Rust. Motoko, the language that Dfinity created for the internet computer, also embraces this concept, and it's fundamentally embraced by Candid. So, and I think that they're quite amazing, but like it might take your mind a bit to, it might take you a bit to get your mind wrapped around it, but algebraic data types are a very powerful concept. We're trying to provide some tools to help you with this match function. It's a little bit in a state of, I guess it's just a little messy at the moment because it doesn't fully work as well as it would maybe in Rust or Motoko. So that's why I suggest you possibly want to use this syntax here. So we can come back to that. I need to double check on that too. Okay. When we get to variants, we'll dive into this concept even more. Okay, a record is going to be your object type. Like I said, this is basically your hierarchical key value pair thing. So notice I'm making a user here. I just import the record type. I wrap an object literal with the record type. And then I use other Candid types as the value types here. So remember, anything inside a record must also be valid Candid. So you can't just put anything you want in here. It needs, the right-hand side must be a Candid type. Also, the left-hand side must be a static variable name. You can't just, they can't be dynamic. They must be static. So just keep that in mind. And these can be arbitrarily nested, right? So, for example, I have a type user here. And let's say I want to make like a blog post or something here. Yeah, these could be principals as well. I have a bunch of blog posts if I want. That would be a vec of blog post, or in the simplest form, you just do a vec. And then my blog post can also be arbitrarily complex. So record's basically like an object. Okay, now variant. I probably should have shown you variant before opt. Variant is very much like an enum. So notice here, this reaction variant has three, I guess they're called different things. They could be called maybe branches, or I think they're called tags in Candid. Let's go look what they call them here. Yeah, they call them cases or tags. So I guess we can call them tags. So we have three tags: fire, thumbs up, and emotion. If your tag doesn't have any data associated with it, then you just put null as the type. If you do want to store something with that tag, then you can put another Candid type in there. And these are similar to enums, but they're more powerful, right? Like a TypeScript enum can be, I think, at runtime is actually a string or a number, but these at runtime can be any valid Candid type. And like I said, at runtime, what's going to happen is the actual value will only have one of these present. So it's like, yeah, if there can only be one thing, it's similar to unions in TypeScript, I suppose, at runtime. If you want this or this or this, then you'd reach for a variant. So yeah, these are just general purpose variants. And then if you notice, opt is a variant, but it only has two values, some or none. So I can show you what opt. See, opt is defined as a variant with just these two values here. So nothing too crazy. Okay, now we get to the func type. So Candid embraces basically higher order functions, more or less. A func gives you, I guess, some of the information that you would need to perform a cross canister call to another canister running on the internet computer. So you define a func like this. You import the func type. You wrap that in whether or not the func is a query or an update or a one-way. So query and update are self-explanatory. It means it's a query. It'll be a query or an update method on the canister that you want to call. A one-way is a one-way when you perform your cross-canister call. And by the way, we'll get into cross-canister calls later in chapter 13, so we haven't really gotten to this concept yet. But a cross-canister call is basically a call from your canister to another canister. And a one-way call would be what we call a notify, where you don't actually wait for the response. So it can be query, update, or one-way. And yeah, sorry. And then finally, you put the actual signature of the func in there. So you put your params inside of this Lambda with their Candid types and then the return type. Remember, all these Candid types, basically, if you're putting types inside of them, they probably need to be Candid types themselves. And so once you have a func type, you can pass it around just like a value. So you could return a func. You could receive a func. At runtime, a func is actually just a tuple. So a tuple is just a heterogeneous array, meaning it's an array with values of different types. They're not all the same type. And the first element of the tuple is a principal. That's the principal of the canister. And then the second element is the actual method to call on the canister. And technically speaking, you should have the information you need to make a cross-canister call, right? We have, the types, and we have the ID, and we have the method. We don't give you a really nice way to do that yet. We're thinking of doing that in Azle 0.18.0, but that's not yet implemented. So in the worst case, you would just construct a service type, which we haven't gotten to yet either. We'll cover all this in cross-canister calls. So maybe it's best to just say, this is how you make a func, and we can talk more about that later. Now we get to the service type. A service is basically a canister. I feel like they're essentially analogous. And if you want to interact with other canisters, you need to have a service definition. And so you define them like this. You make a class that extends service, and you basically put the method definitions on. And again, you define the parameters, you define the return type, and you wrap everything in this thing called a call result. Azle 0.18.0, which is coming out very, very soon, makes, I think, a lot of this, in some ways, much nicer and more uniform. So we don't have like random classes and random annotation stuff. It's all basically the same unified syntax. But for now, this is how you do it. At runtime, a service is just an instance of this class with a principal, and a service has the ability to perform a call to another canister, and you do it like this. So this would be an instance of a service. It's already loaded up because it's being passed into you with the principal, and then you can just take your method, update one in particular, and then you can call it. A principal is essentially an identifier on the internet computer. So there's a specific format for these identifiers. Canisters have IDs, which are known as principals. If you have like a key value pair, if you're trying to log into an internet computer application, you will have a principal. And yeah, I mean, that's just the basic concept. They have a textual format, but they're really a binary encoding. So if you import this principal type or class, then it has some methods for you to translate between text and binary, etc. Okay, these last few types aren't that important, but they're here. Reserved, you can mark things as reserved. It basically lets you, I don't even know. Let's go read here. it can be used to remove method arguments. So I guess if you have arguments and you no longer care about the middle name, although Candid will not prevent you from changing the signature to this, apparently that'd be a bad idea. So if you want to deprecate something, I guess you'd use reserved. These are quite esoteric. And the empty type is also weird. It's a type without values. And they even say here, practical use cases are relatively rare. But basically, you could make something that would never return or something crazy. So, yeah, those are all of the Candid types. I think we should pause and answer questions before we move on. Any questions?
Excuse me.
Yes.
May I ask you a question?
Yeah, go ahead.
Actually, today I tried to deploy my project, but I got a lot of errors. And when I asked my question to Discord, one person told me that the classes are not supported in Azle. I would like to know that the object-oriented principle is not supported in Azle or not, because right now I saw that in a service part that the keyword classes and extending uses in Azle, but right now I got confused about this different answer.
Yeah, so these types, you need to define them however they're defined in Azle. So in this case, service, I believe, is the only type that uses a class. In Azle 0.18, which will be released very soon, we remove all classes. There are no more classes. So as a framework, we are not encouraging classes. I don't think we're necessarily discouraging classes, but the API doesn't use any classes. At least it doesn't ask you to define any classes. That being said, if you want to make classes to do your own stuff, you can do that. But when it comes to defining the parameters and the return types of your methods, you need to use the actual Candid types. And so those cannot be classes. Does that make sense?
Yes, so as I understand, I cannot create my own class. Yes?
You can make your own class, but you can't. If you have some internal algorithm, you can make classes and stuff. But when you come to return a value from a query or an update method, you need to convert that class into an actual Candid value.
I got it. Thank you very much.
You're welcome. Okay, anyone else? Okay, while we're waiting, I do want to test something. I want to make sure this syntax is correct for you guys. And then we will move on to stable structures. So let's pretend we receive this. And if we say if sum in opt bool, return opt bool dot. Huh. That's very intriguing to me. Just a second. Let's go look at a real example lately. What would happen? Well, okay, I thought this syntax was the one we wanted you guys to use. But yeah, worst case, you can use match. And yeah. Well, yeah, not sure on that one. Okay. Okay, if there are no more questions, we can move on to stable structures. Okay, so chapter 11, candid types. Those are the basic and with records of variance and offs of x and such complex types that you can use. But everything I showed you, if you noticed, was stored on the heap, right? Well, actually, it was probably all stored on the stack. We didn't store any global variables. Notice here, remember from our previous lessons, I believe, this message variable here is stored on the heap, right? And there's a problem with the heap. The heap is going to be wiped every time you deploy your code again, I guess, every time you deploy your code. So if you're writing your application, if you build an entire database out of records and blog posts, and you store it like this, and you have users stored here and blog posts stored here or something. You can make a whole database like this, and you'd have up to 4 gigabytes of space. And if you only deploy your application one time, then that could work really well for you, and it'd be super quick to develop and not super complicated. But if you need more than 4 gigabytes of space, and if you want to ensure that when you upgrade your code, with some caveats or nuances around the actual structure itself, but if you want to make sure that when you upgrade your code, you don't wipe everything, then you can use a special data structure called a stable data structure that stores information in a separate memory location from the heap memory. And this location is called stable memory. And last I checked, stable memory is 64 gigabytes. So it's actually quite large. And yep, it persists across upgrades. It gives you a really nice, familiar API. It'll feel like just a generic map that you're going to be used to in various languages. You have to specify a couple properties on it at the moment. Azle 0.18 actually removes a few of these things, which is very nice. And then right now you can't migrate your stable data structure once you create it, basically. So once you make one, it's basically set in stone. You can make a new one and migrate over to the new one. So let me just show you the basic concept. You import the stable B-tree map. That is the one stable data structure that we have supported right now. And the stable B-tree map, this is a general purpose map. So it's going to allow you to do key value pairs, just like in a like a normal JavaScript object, but they will be stored into stable memory. So every time you insert or delete or something, right then the values will be serialized and sent to stable memory, which is very nice. So here we are creating a stable B tree map, you define your types. So the keys in this case will be NAT8s, and the values will be strings. You define a memory ID. This is a number between 0 and 254. So I usually just start at 0, and if I need more, I'll just add more. Then you need to specify the maximum size of your keys and the maximum size of your values in bytes. So I think these are just rough estimates, right? So I have up to 100 bytes for the key and up to 1,000 bytes for this value. Now, this is really unfortunate to have to do, because how do you know how big, especially if it's a string, like how do you know how big it's going to be? Because the user can type anything they want. And what if you have a vec? What if you're storing audio files? You don't know exactly, I don't know how big the recordings will be. So very unfortunate, but it is going away in the next release of Azle. So that's really cool. But for now, you can you can just reason through it, come up with some reasonable numbers, or there's a little heuristic protocol I'll show you at the end that helps you figure it out as well. I mean, that's the basic concept. You can put essentially any Candid key or value in here. You'll want to be careful with, if we go down to caveats, floats, services, funcs, anything that doesn't have like a strict ordering, you'll want to be careful making keys out of those, because your searches might be very inefficient. I also believe that problem has been solved in Azle 0.18. I think even services, function floats will have, I mean, there might be some caveats to that, but just think about your keys. If you do need strict ordering, think about those types. Think about if it's possible to actually compare these things and get an order out of them. So once you have one of these bad boys, these are all the methods available to you. You can call contains key, that just returns a Boolean. You can call get, if you pass key in, it will turn an option with the actual value. Insert, pass in the key and value. Is empty is Boolean. Items, that will just return all items as a tuple with the key and the value. Keys gives you all keys. Length gives you the length. Remove, delete an item, and then values gives you all just the values. So yeah, I mean, this is everything you need to go crazy and start basically building your own database. I mean, under the hood, relational databases are built out of similar data structures, like B tree maps or B plus maps. So my project Pseudograph, which is a GraphQL database on the intercomputer that we have not revived yet, but the plan, we'll see how it goes. But we are planning to look into it again, at least, is B tree maps under the hood. Not stable B tree map yet, but is B tree map. So this is a very versatile data structure. So once you have one, you can actually start to, build, I don't know, whatever you want, right? So right here, you can see that basically I'm creating one stable B tree map per basically table. Like this is basically like a database table, right? Where each item is a row in the table, and the primary keys are principals, and the columns, this is a column basically. This column, this column, this column. So very similar to basically database tables. And then I'm just making a normal application. If I want to create users, I'll do it like this. If I want to get all the users out, do that. If I want to get a specific user, I can do that. It's a very simple CRUD application. If I want to delete a user, I would do that. And the same for recordings. If I want to create a recording, I pass in the actual audio here with some other information. Doing things like one-to-many or many-to-many relationships can also be emulated. I mean, done basically. And yeah, just basic CRUD functionality. And this is just showing you how you could make a principal like a unique random identifier, essentially. And yeah, the documentation just gives you a little bit more information on these. Probably the most important thing to know at the moment. I mean, yeah, I think that's the basic thing, right? You just, each stable B tree map acts as a database table. And the hardest thing for you is probably going to be specifying the maximum key and value sizes. So if you just wait for Azle 0.0, this problem will go away. But if you're getting started now, what my recommendation is basically take the key size and set it to something like 1 or 10 or something like very small, something you know is smaller than any actual value. If you set this to 1 and this to 1, or something very small, when you try to insert into it, you should get a key too large or a value too large error. And the error will tell you how big your value was. So then you can use that information to start getting an intuition for how big these values should be. Or you could just make them much bigger than you'd ever need. But remember, if you make these too big, then you'll have an inefficient memory storage under the hood, right? You'll be storing a lot of empty information. So you probably don't want to do that. And yeah, we went over the caveats with the keys, but that's the basic idea. So yeah, we went over Candid, and we went over if you actually want to do real database stuff for the moment, stable B tree map is probably your best bet. In Azle 0.18.0, we are swapping out our JavaScript engine, which is going to give us better NPM support. So I'm hoping that we can provide things like SQL.js and GraphQL just right off the shelf. So those will be some alternatives that you could use as well. And hoping to have FS work, like Node.fs, basically, at least an in-memory file system, so up to 4 gigabytes of a file system. Yeah, there's a lot of stuff coming, but the stable B tree map is a good choice right now, at least. So yeah, that's the presentation for today. If you guys have any questions, I'm happy to answer.
Gordon, I have a question about the stable tree map. So
Yes.
let's say we deployed our canister and then we changed our code. So even if we redeploy, the previous deployment will be still alive in the canister, right?
What do you mean by the previous deployment?
I mean, let's say we saved some user information and we change a different part of the code, different functionality. So that user information that we didn't touch for the updates will be still inside the canister.
Yeah, that's what the stable B tree map does for you. Yep. As long as you keep the interface of your stable B tree map the same, like the key units and values, if you change some other part of the code and redeploy, your stuff stays. That is the main advantage. One of the main advantages of the stable B tree map. If instead you were not using a stable B tree map, but you were just using a normal map on the heap, then that would be wiped.
And I have one more question, actually. What is the advantage of keeping this data on chain? All this data, like let's say user information, let's say MP3 file, like in music. Can't we keep them off chain? And
I mean, what do you mean by on chain, right? Because the internet computer is just a decentralized cloud. So where else would you store it? If you don't want to use the internet computer, then you would just store it on AWS. But if you do that, how are you going to get the data into your canister? So basically, you might be just asking why should you use the internet computer, right? Which we have discussed. So if you've already decided to use the internet computer, then I don't see why you'd want to store your data anywhere else unless it's too expensive on the internet computer. But if you store it somewhere else, it's going to be difficult to get the data in. You'd have to do HTTP requests or something to like pull the data in and compute on it.
All right. Okay.
And on chain, on chain on the internet computer just means, it's stored on the internet computer nodes. So you'll get all the security of the nodes, and the decentralization, and all the reasons that you'd want to use the internet computer in the first place.
Yeah, also, yes, Umut, I would like, because I know you already passed the course of the decade course. The decade course is also in TypeScript, and Jordan will review the TypeScript course on decade. Yes, if you can share with us a little bit more information, what was for you the stoppers, or your more difficult part, you can share with the rest of the team. Maybe Jordan also could help you, or give you more advice on that.
Sure. So in general, like I found it good, and the course outline is good, and it helps to like get the basics, and the implementation like makes you practice about what they showed. What I found difficult, well, the challenging part is like adding extra functionalities other than what they showed in the course. Let's say, so they are showing basically CRUD application, and like adding some extra functionalities depending on the use case was the challenging part, but of course, like it's for teaching you more. So I need to do some improvements, because I think I couldn't, like I spoke with the team. They said like I got 60 for now. So they gave me time until 2nd of October. I will work on it to add some extra functionalities.
Thank you.
Yeah.
And Jordan, I have another question. I'm not a developer, but in your opinion, what chapters are? I know like every chapter is important, but what is the most difficult chapter for like people, or because I cannot see like a lot of questions for this chapter today, but I think for sure like people have questions when they start, to dive in more. Yes, any recommendation from the Azle book that I know all the chapters are important, but are you maybe can recommend like focusing in something like you think is especially difficult for new, or for beginners, or for new developers?
If you master chapter 11 and 12, what we just went over today, then I feel like that really, that's, I don't know. I feel like it's hard to answer, because all these concepts you need to understand. So query and update methods, pretty simple. Candid, everything we talked about today. Maybe that's one of the hardest things to get your head around. You just need to understand, you need to think in terms of these types. Once you think in terms of these types, then you just grab your stable B tree map, and your keys and values are any Candid value, essentially. Your query and update methods, your parameters and return types are any Candid value. And then we're going to get into much more advanced stuff in the subsequent chapters. So I think you just need to have this solid understanding. And probably the hardest stuff comes after this, I would say.
Good to know. Okay, thank you.
Yeah, sorry. So the Candid was something completely new to me. So we have to just go through it and read more about it, maybe watch the clip again. Um, I learned a lot of things from you today. I just have to go over it and just recheck everything again.
Yes, you're welcome. Yeah. Yeah, and keep in mind, they're very simple. It's nothing crazy. So um, I think a lot of times in computer science and in programming, I think as learners, we think these concepts are more complicated than they actually are.
Mm.
Yeah, the candid types, they're just types. Um, they're very analogous to what you're already doing. So hopefully it won't be too bad. But yeah.
Also, Taha, I know you are a student from UBC, University of British Columbia, and we discussed about you are super interested in TypeScript and Python and deploy your own project on the internet computer. Can you like give us some feedback? What do you think is for you is difficult to start diving the Azle Book, or you have any feedback, Taha?
Sure. So basically, yeah, as you mentioned, I started working on internet computer using the Azle Book. So basically, everything is just straightforward, as also Jordan was talking about. I mean, I know mostly most of the contents that Jordan was talking about during these sessions, but the point that sometimes is a bit hard to handle for using the ICP is that when you confront the error, especially when you're dealing with the projects that are recently been implemented, is that when you confront an error, there is not that much of resources to, for example, fixing that. Similar to, for example, let's say we have a normal Python or some other things in general in other projects. So that's basically what I have more problems. For example, I was trying to provide a storage system on ICP, and I had some challenges, for example, dealing with the projects implemented after facing some errors. For example, I need to go inside deeply the libraries that were implemented inside the projects to see what is the problems. But except for that, I think everything is just very straightforward. And yeah, so that was my experience so far.
Yep, that makes sense. The errors on the internet computer in general, I think, are a little difficult. So
yeah, because I mean the Discord channel and also I think there's a Telegram channel that I joined. I joined it. It's very good. For example, you can ask the questions, and sometimes you can find the answers. But for example, like in a Stack Overflow or maybe some other resources out of the, for example, Definitive website, sometimes it's hard to find the answers for the specific errors that you're confronted.
Yep. And hopefully you guys all know about the Dfinity forum. But forum.dfinity.org is like the #1 place to find. I don't know if everyone. There's years worth of people having their own errors and posting and stuff. So oftentimes, if I can't fix something else, I will go straight to the forum and I'll search there. So. But yeah, that is good feedback. We have spent a lot of time on Azle air handling. So unfortunately, in Azle 0.18, we have started from scratch on a lot of things, so that the errors are going to be different. But I think that's very good feedback and something very important. We really want the Azle air experience to be similar to Rust. Rust has probably one of the best compiler errors of all languages. So hopefully we'll get there.
Right. I mean, actually, that makes sense because it's just been released. I think it's a new one, so that makes sense. That, for example, when you face an error, it's a bit harder to find the answers. But for For example, my idea was something like, for example, if we have the patterns of error at this point and the solutions that might be helpful, that would be very good at this point.
Oh yeah, I see it. So even like a chapter in the book, basically like common errors, and just show them like, hey, these types of errors are resolved in this kind of way.
Right. Yeah.
Yeah.
Okay, if it's not any other questions, we can wrap it up. We are like 2 minutes over time, but yeah, thank you so much, everyone, for your time today. Let's continue the next session this Thursday for the next chapter number 12. Yeah, thanks a lot, Jordan. You want to say your wrap it up or last words?
Yeah, just good luck. Good luck with Candid and Azle Book reps.
Okay. Thank you, guys. See you on Thursday.
See you. Have a good night.
Yeah, have a good night. Bye-bye. Thanks.